MASM, Meta-Analytic Structural Equation Modeling. That's something you have probably heard a lot these days. Most recent guidelines for doing a proper meta-analysis ask you to conduct a MASM, meaning you have to first run your meta-analysis and then run an SCM calculation based on the results of your meta-analysis. Doing the calculations for a meta-analytic correlation table, which is the starting point of MASM, however, is not very easy. It takes a lot of calculations. I tried to do one using Excel sheets myself a few years ago, and it took me about 2 months for a 17 by 17 correlation table. It wasn't really fun, but the good news is you can run this very easily in HubMeta in just a matter of minutes. Let's see how we do that. All right, our goal is to produce a meta-analytic correlation matrix like this, where each of the cells in itself is a meta-analysis. So below the diagonal here are the correlations. These are meta-analytic correlations. And up top, you have the number of studies and the total aggregate sample size for each of them. So basically, you feed this into your structural equation modeling program and you run your analysis. Of course, there are other methods for MASCM. The most important one is the methods developed by Mike Chang, and you can use HubMeta to produce the data required for that analysis as well. Let's go to HubMeta. We'll go to Analysis, to Meta-Analytic Correlation Table, and click your Filters Format. And here what you have to do is to select the variables you want to include in your correlation table. Okay, so here you need to choose a few variables. International experience of managers, intensity, knowledge, scope, speed. And I think it's good. So let's click on next. So I've chosen 12 variables, and this is doing a meta-analytic correlation table. So it's actually running 66 different meta-analysis all at the same time to produce that table. Running that manually can take a huge amount of time, but it will take HubMeta about a few seconds. So in less than a minute, it will produce our results. And here we go. So that's the correlation table you needed. One thing you want to make sure you fix just after your table is produced is these empty cells. What these empty cells mean is that there were not enough studies to calculate this meta-analysis. So basically, there were not any studies in the articles you have coded that had a correlation, for example, here between foreign language of the entrepreneurs and knowledge intensity. And in many cases, you would see that there are a lot of missing points here. And in this case, I will just make the decision to remove this variable from my analysis so I can rerun my analysis using that. The second thing you want to look at is, of course, your outliers. And the way HubMeta shows outliers here is it would underline any results where there might be an outlier issue. Now, you would need this table for two purposes. First, you obviously want to export this and report in your meta-analysis, something like this. So you have the results as a CSV file. That's what the CSV file looks like, exactly like the way you have to report it. Just need to clean it up. And the second is when you actually want to do a structural equation modeling. Here, we will give it as a .r file, which you can open into your R Studio or whatever R platform you're using. And it will look like this. So this is the correlation table. These are the codes based on the library Lavaan for latent variable analysis, and there are some sample codes here which you can use. I will explain this further in another video. And finally, you can use this export as wide format option. The file that is generated using this can be used for the massam methods of PyCharm because that's how they need the data to be prepared.